This is a video on how to maximize the area of a rectangular space given a set amount of fencing or perimeter. So the first thing that we want to look at is how do we find the area of this shape, which would simply just be x times y, length times the width, and that's the area that we're trying to look at. So we have an equation, a equals x times y, 3 variables, and I don't really feel like doing multivariable calculus. So we're going to then look at the perimeter of that same shape, which is equal to 2x plus 2y, and for our example, that is equal to 300. So what we need to do is solve for either x or for y in terms of the other one. I'm going to solve for y, so I'm going to subtract 2x from both sides. And we get 2y equals 300 minus 2x. And to finish solving for y, I'm going to divide by the 2, which gives me y equals 150 minus x. Once I have my 150 minus x equals y, I'm going to replace it. So I'm going to get a new area equation. The original x stays. The y is replaced with 150 minus x. I distribute my x, so I get 150x minus x squared is my area. Now, this is my equation. I have two variables, and hopefully you can recognize that this is a quadratic equation, and the maximum area is going to happen at the vertex. So now we just need to find our vertex. So if I rewrote this in a more familiar form, you can probably see we have our a value, which is -1, our b value, which is 150, and our c value of 0. Now, typically with quadratics, you're either looking for the vertex or you're looking for the roots. The roots, you would need the quadratic formula. The vertex, you need to remember that -b over 2a is the x-coordinate of the vertex. In this case, -150 divided by -2. 2 times that -1 that you can't see up there, which is 75. So the x value of my vertex happens at 75. Now there's a few different ways we can find that area. We could plug in 75 into our equation, 150 times 75 minus 75 squared, which is 5,625. And since we're looking at feet, this is square feet, and that is my maximum area. The other way we could solve this is to kind of think about our situation. We have this rectangle, and we've learned that x is 75. So I've used 75 on the top, I've used 75 on the bottom. That leaves, well, if I had 300, and I used 75 on top and bottom, that leaves 150. Oh, that means that y must be 75 as well, and I could just multiply the 75s together. So it's also just x times y, find the y, and multiply them. Same value. And that's how you can maximize the area of a rectangular region.